In this video, we are going to look at parabolas, but kind of in a different light than probably what you've seen before. So this is the geometric definition of a parabola, and that is that you have a set of points on a plane they're all equidistant from a fixed point called the focus, which I have labeled right here. It's always inside the parabola, and a fixed line called the directrix. So that's down here. I have this line, this purple line. So the idea is every single point on this parabola would be the same distance away from this focus as it is from this line. So an easy example would be the point 0, 0 here. That is this distance up to that focus, and then the distance down to this line. That's the exact same distance. The point here at the end of this blue line, that distance, a unit of 1, is the same distance here to this purple line. So every single point on this parabola is going to be the same distance from the focus as it is from the directrix. And then we would get a parabola with that. This blue line in between is what we call the focal diameter, and that kind of helps us with how wide the parabola is going to be. So the focal diameter is just a line segment through the focus where the endpoints are on the parabola. So we're going to look at a couple different ways here of these parabolas. We're going to have a vertical parabola and a horizontal parabola. And the equations for those, if it's a vertical parabola, it's x squared equals 4py. P is going to be some number that are going to be concerned about. It's going to help us to figure out some things about our parabola. But then if it's a horizontal, it's y squared equals 4px. So same equation, but the x and y are switched. In both cases, the vertex is at 0, 0 of the parabola. The focus inside the parabola is going to be at 0, p if it's vertical, and p, 0 if it's horizontal. So this would be a point on the y-axis. This would be a point on the x-axis, determining which way the parabola is going to go. The directrix, that line y equals negative p, is a horizontal line if we have a vertical parabola. It is a vertical line, x equals negative p, if we have a sideways parabola. And then in both cases, the focal diameter is the absolute value of 4p. The length of this line would be the absolute value of 4p. And again, 4p is going to be the number in front of y or in front of x. One more thing to note is that if p is a positive value, your parabola will open up or to the right. If p is a negative value, then your parabola will open downward or to the left. So we're going to jump into some examples here. First one we have a parabola with a vertex of 0, 0 and a focus of 0, 2. We want to find the equation, then we want to sketch the graph. So how do I know which way this parabola goes? Well, if we think about the points that we're given that the vertex of this parabola is at 0, 0 and the focus is at 0, 2. Since the focus is inside the parabola, this parabola is going to open upward, and then we know that it is x squared equals 4py, right? So it's x squared if it opens upward. So x squared equals 4py. The focus, the coordinate points of the focus are 0, p, so I know that p is 2, which means our equation is x squared equals 8y, right? 4 times 2 times y, which means 8y. So x squared equals 8y is the equation. The other piece of information here that I would want before I graph this is, what is the focal diameter? And I know it doesn't ask this, but remember the focal diameter, it says the absolute value of 4p. Well, 4p, when you just have the equation written, 4p is the number that you have in front of that non-squared variable. So 4p is equal to 8. And the focal diameter is the absolute value of that, because it's always a positive number, because it's a length of a line. So that's going to be a focal diameter of 8. So what that actually tells me is that through the focus, we're going to have a diameter of 8, which means if I go out 4 units through the focus to each side, my parabola is going to be that wide, right? It helps you with how wide the parabola is going to be. So it's going to look something like that. The directrix in this case, I don't have that drawn yet, but the directrix is y equals negative p, so it's going to be y equals negative 2. So if we were to draw a line here at negative 2, that is that line that every point on our parabola is the same distance from that line as it is from that point of the focus, which is at 0, 2. Next example, find the focus, directrix, and focal diameter of y equals negative x squared and sketch the graph. So the first thing you want to do, notice in our equations that the squared variable is the one that's by itself in the equation. So the first thing I'm going to do is isolate the squared variable, which means I'm going to divide by negative 1 here, so that I have x squared equals negative y. In order to find the other information, we want to find the value of p. So after you do that, you're going to take this number that's in front of your non-squared variable, and you're going to set that equal to 4p. So 4p equals negative 1. P is negative 1/4. Okay, so which way does this parabola go? Well, the vertex is 0, 0. And if p is negative 1/4, it's x squared. X squared means that we have a vertical parabola. But because p is a negative value, that means our focus, in this case, is at 0, negative 1/4. So if I go down 1/4, so what I'm actually going to do is I'm going to make this be a value of negative 1. I'm going to make every 4 boxes be 1 unit. That'd be 1, and then over here we'd have negative 1. At negative 1/4 then, which would be only 1 box down, that is where the focus is, which would tell me this parabola opens downward. Right? The directrix would be at the line y equals negative p, but because p is negative 1/4, this is going to be y equals positive 1/4, so I have a horizontal line here. Your parabola should never cross the directrix, by the way, so make sure that that doesn't happen. It's always around the focus and away from the directrix. And then the focal diameter is the absolute value of 4p. Now, again, I can just look at my equation, and whatever that number is that I set 4p equal to, that is the focal diameter, just make it positive. So the focal diameter is 1. So what that tells me is through the focus, this parabola has a width of 1. Now, if I'm making each box be 1/4 of a unit, that means that a total width of 1, I need 4 of those. So going from negative 1/2 to positive 1/2 would give me a length of 1 there, so that my parabola would look like this. Okay, last one. We have 6x plus y squared equals 0. Kind of the same direction here. I want to isolate the squared variable, so y squared is going to equal negative 6x. I want to find the value of p, so 4p is equal to negative 6. So p, if I divide by 4, is going to be negative 3/2. Again, the vertex will be 0, 0. And then p is negative 3/2, but this time we have y squared. So if it's y squared, it's a sideways parabola. So the focus, the p-value, is the x-coordinate here. It's negative 3/2, 0, and our parabola is going to be sideways. So negative 3/2. If I make each box a half, so that would be, this would be negative 1 here. Positive 1 would be the second box, and so forth. If I did that, then negative 3/2 is going to be right here. You don't have to do that. You can graph it however you would like, but if you change the scales on your x and y axis, it does make it a little bit easier to graph these sometimes. So focus is negative 3/2, 0. The directrix is x equals, because it's a vertical line, x equals negative p, so the opposite of p, which would be positive 3/2. So that means we have a vertical line here at x equals 3/2. And then the focal diameter is the the number that we set equal to 4p, but positive, so 6. Now, if I scaled this y-axis the same way I scaled the x-axis, then this would be 1, this would be 2, and I would have 3 up here at 6, right? So if I did that, just so that my scales are the same, negative 2 and negative 3, then a focal diameter of 6 means I need to go 3 in each direction. So I need to go up 3 and down 3 through the focus so that that has a total length of 6 units, which our scale shows 12 units there because we're scaling by a half. But then our parabola would look something like this, and that should go through that. Okay. And there's a parabola open to the left. So I'm going to show you through Desmos what this kind of looks like to help you with this as you graph these. So the first one, we found out x squared equals 8y was the equation. You see the focus at 0, 2. You see the directrix at y equals -2. If we take that away and look at the second one, we had y equals -x squared with a focus at 0, -1/4, and a directrix at y equals 1/4. It may help to zoom in to see that equidistance between the focus and the directrix here. But that's what you have there. And then the last equation was 6x plus y squared equals 0. We did manipulate that a little bit to make it look different, but it does look like this with a focus at -3/2, 0, and a directrix at +3/2. Looks like this. So you can use Desmos to kind of help figure those things out once you find that information, just to make sure that your information is correct, and then it should look where the focus is on the inside and the directrix is on the outside.